Hey guys, Mr. Rubo here, getting ready to do another video on law of sines. Um, Law of sines is really nice to use because we can use it just like law of cosines. We can use it with any type of triangle. Um, and so we have two ways of writing it. The first way, and remember, capital letters are the angle, and then the lowercase letters are the side across from it. So here we can write it where it's sine of A over A equals sine of B over B equals sine of C over C. And when we're doing problems, we're going to use only two of the fractions to set up the problem. Okay. Now this also works if you do the reciprocal of everything. So if you do the reciprocal of all those ratios, if you take the side of A over the sine of A equals lowercase b over sine of B equals C um, over sine of C. So once again, you can use whichever ones you want. I will say it's easiest though if you choose the one where the variable or the side or angle you're looking for is on top. So if you're looking for a side, like we are in actually both these examples, we actually want to choose the one that has the sides on top. And it kind of gives you a hint here. If you want to find the angle, use these ones. Technically, you could use either one. It just the solving's a little bit nicer when you have the variable on top. So here, the biggest thing with law of sines is you have to have an angle and a side that correspond. So one angle and a side across from it, you have to have at least one. If you don't, you can't use law of sines. Probably end up using law of cosines. So because we're looking for A, I'm going to say A over, then the angle across from it is 30 degrees. So we're going to say sine of 30 degrees equals, and then the side that corresponds to the 110 is the 14. So there's the setup, and now it's a nice easy problem to solve because we want to solve for A, so we just need to multiply both sides by sine of 30. And technically we can do the sine of 30 without a calculator, but the sine of 110, we will need one. So go to my calculator here, and make sure calculator is in the correct mode, right? Don't want to do all this work and realize we're in radians. And then you're just going to type 14 divided by sine of 110 times sine of 30, and you get that A is 7.45 units. Okay. So yeah, fairly straightforward. And you can see here we were given an angle, and a side. So this is one of those cases where we can use law of sines always, when we're given two angles and then the side next to technically either one of the two angles. All right. So now, another time we can use this is here where we have angle, side, angle. So here's the angle, here's the side in between, here's the other angle. Now, I had said we need a pair of corresponding sides and angles. And right now, we're only given this one side. However, because we have these two angles, it's a triangle, we can figure out, oh, these two are 100, so then this has to be 80 degrees. So you may not be given this third angle, but you could easily solve for it without too much fret. So now there's our one that we have both the angle and the side of. Here's what we're looking for. Once again, we're looking for a side, so let's put that on first. X over sine of 60. Once again, we could solve that without a calculator, but this side we can't. 17 over sine of 80 degrees. Once again, nice, easy to solve. Sine of 60 times sine of 60. So x will be, we're going right to the calculator, 17 divided by sine of 80 multiplied by sine of 60. And we get 14. Ooh, that's not what I wanted, right? 14.95 units. Okay. So yeah, that's law of sines for angle, angle, side, and then also angle, side, angle. There's a third situation that you can use law of sines for, which is side, side, angle. And that one, though, is the ambiguous case. And so I have another video that goes over that in a little bit more detail, because that one is a little bit tougher, a little bit more ambiguous. Okay? So hopefully you enjoyed the video, and have a good one.